Here's an example of solving a linear equation that has lots of fractions running around in it. If you remember, I said that if you don't want to deal with fractions, one of the things you can do is get rid of them as soon as you can. And so that's a good strategy here. If we multiply on both sides of this equation by the right numbers, we can make the fractions go away. You can either do this all at once if you recognize the least common multiple of the denominators that you see. And if you don't, you can just do it one at a time. So let me just do it one at a time as an example. Let's take this equation, and we see that one of the fractions has a 7 in the denominator. So let me multiply both sides by 7. So here's what that would look like. So, and notice here when I say I'm multiplying both sides, I'm distributing that multiplication of 7 through whatever addition and subtraction I have. So I've multiplied, basically I've multiplied this by 7 and this by 7, and here I'm using the distributive property to push the 7 times through. So that multiplying by 7 allows me to cancel out the 7 in the denominator. If you are concerned about that, remember that we can cancel common multiplicative factors, and so that really, if I wanted to show the steps there, I would say that's 7 over 1 times x plus 4 over 7. When you multiply fractions, you multiply the numerator and multiply the denominator. So I have 7 times x plus 4 over 1 times 7. Now 7 is a common multiplicative factor, and so I end up with just the x plus 4 term. And so that's what's happening. That's what's happening there. So I end up with x plus 4 plus 7 times x plus 2 over 4. And again, I'm thinking of that as 7 over 1 times that fraction equals 7. So that's what happens when I multiply both sides of the original equation by 7. Now I could, at this point, rearrange some things. If I wanted to, I can certainly subtract 4 from both sides and move some things around. But I'm going to go ahead and just keep going with the goal of getting rid of the fractions before I deal with anything else. So I still see I have a fraction, still in this problem, that has a denominator of 4. And so I'm going to multiply both sides of this equation by 4. So 4 times all of this, and 4 times all of that. So literally everything on the left times 4, everything on the right times 4. So again, when I distribute that multiplication by 4 through, I'll have 4 times x plus 4 first, that's here, and then I'll have 4 times this term. So I'll have 4 times 7 times x plus 2 over 4. And over here I have 28. So just like before, the stuff that I wrote down here, when I multiply by 4 times a fraction that has a 4 in the denominator, that's going to cancel out. And so what I have at that point, let's move this down, is 4 times x plus 4, that's still left over from up there, plus 7 times x plus 2 equals 28. And so once I get to this point, I can solve this like a normal equation. I can distribute my multiplication by 4 through here and get 4x plus 16 plus 7x plus 14 equals 28. And then I should be able to solve it. I'll have 11x plus 30 on the left, so 28 on the right, and so everything should be okay. So the key is that multiplication, when you multiply a fraction by the number that's already in the denominator of that fraction, then that number will cancel out. So in our original equation up here, multiplying this fraction, this thing on the left, by 7 and by 4 will eventually kill all of the fractions. If I want to speed up that process, you can say multiply by 28. That's the least common multiple of 7 and 4. 28 times a fraction with a 7 in the denominator is going to have a 7 cancel out from the 28 and a 7 cancel in the denominator. And similarly, 28 times a fraction that has a 4 in the denominator, the 4 is going to cancel out in the denominator, and a multiple of 4 is going to cancel out in 28. So if you do that, you'll end up in exactly the same spot that we were basically you'll get to this if you multiply both sides by 28 in your first step. But this is a good example of a problem where we place a high priority on just getting rid of the fractions, and the way we can do that is by multiplying on both sides by the same number, but by a number that's appropriate to cancel out the denominators.